Hello everyone. In this video, we are going to look at how 5G Standalone is being used for critical IoT. The starting point is a recent service launch from Telia in Sweden. But the aim here is not just to talk about one operator or one announcement. The bigger question is this: what does 5G Standalone actually change for IoT? For many years, IoT has been associated with sensors, meters, trackers, and devices, sending small amounts of data. Sometimes we call this the Internet of Small Things. That is still very important, but there is another category of IoT where connectivity has to be more predictable, more secure, and more responsive. This is where 5G Standalone starts to become interesting. With the 5G core network slicing and more advanced traffic handling, operators are now able to offer connectivity that is better suited to applications in emergency services, energy, transport, industry, healthcare, and other essential sectors. So let's break this down step by step. The first thing to understand is that not all IoT is the same. Many IoT devices only need occasional data transfer. A meter may send a reading every few hours. A tracker may report its location from time to time. A simple sensor may only need to send a small update when something changes. That kind of IoT is important, but it is not usually time critical. Critical IoT is different. Here we are talking about applications such as real-time video from the field, remote control, industrial automation, healthcare monitoring, connected transport systems, and energy infrastructure. In these cases, delays or disruptions can have a real-world impact. If a video feed from an emergency response vehicle is delayed, or a remote control command in an industrial environment is unreliable, the consequences are very different from a delayed meter reading. So the key point is simple. Standard IoT connects devices, but critical IoT supports applications that need reliability, responsiveness, and trust. To understand why 5G standalone matters, we need to compare it with 5G non-standalone. In 5G NSA, the device can connect using both 4G and 5G radio. This is known as dual connectivity. The 5G radio brings extra capacity and performance, but the network still relies on the 4G core. That was an important step in the early deployment of 5G because it allowed operators to roll out 5G radio services more quickly. But 5G standalone is different. In 5G SA, the 5G radio connects to a 5G core. It no longer depends on the 4G core infrastructure. This is not just a technical detail, it changes what the network can do. The 5G core is designed for 5G services from the ground up. It supports more flexible service control, better security architecture, network slicing, and more advanced ways of treating different applications differently. So 5G SA is not simply faster 5G, it is a different network architecture. The 5G core is often where many of the real 5G capabilities become possible. Think of it as the brain of the network. It allows the operator to apply intelligent traffic and policy control. That means different applications can be handled according to their needs, instead of treating everything the same way. It also brings stronger security capabilities, including authentication, encryption, and data protection. For critical IoT, network slicing is one of the most important capabilities. A slice can be configured for a specific type of service or customer need. For example, one slice may be optimized for very reliable low latency communication, while another may be optimized for large numbers of low power devices. The 5G core also helps with scalability and efficiency. That matters because IoT is not just about a few devices. In some sectors, it can mean thousands or millions of connected endpoints. The key message is this: 5G SA plus the 5G core creates a smarter network that can support different applications in different ways. Network slicing is one of the most talked about features of 5G standalone, but it is often explained in a complicated way. A simple analogy is a road. Without slicing, all traffic shares the same lanes. Cars, buses, emergency vehicles, and delivery trucks are all mixed together. When the road gets busy, everything slows down. With slicing, traffic can be separated into dedicated lanes. One lane may be prioritized for emergency services. Another may be designed for high-performance video. Another may support massive IoT devices such as smart meters and sensors. Another may be simple best-effort connectivity for general data. The physical network may be the same, but logically it can be divided into multiple virtual networks. Each slice can be designed with different characteristics: reliability, latency, security, capacity, or cost efficiency. This is important for critical IoT because not every application needs the same thing. A smart meter does not need the same network behavior as remote industrial control. Video surveillance does not have the same requirements as asset tracking. Emergency services may need a different level of priority compared with general browsing. Network slicing is about giving the right performance, reliability, and security to the right application. So what does this mean in practice? In emergency services and public safety, critical IoT could support real-time video from the field, mission-critical voice and data, and faster situational awareness. In energy and infrastructure, it can support remote monitoring of assets, smart grid automation, and early fault detection. In transport and mobility, it can help with passenger information, tracking, telematics, and safer operations. In industry and automation, 5G SA can support remote control, predictive maintenance, and productivity improvements. In healthcare, it can support remote patient monitoring, telemedicine, and better access to care. And in smart cities, it can support video surveillance, environmental sensors, and connected urban infrastructure. The Telia example is useful because it shows this being positioned over a public 5G network, not only inside a private campus or factory. According to the announcement, Telia's Swedish 5G network covers 99.9% of the population and more than 94% of Sweden's land area. That wide area coverage is important. It means critical IoT is not limited to one building or one site. It can support use cases that move across cities, rural areas, transport corridors, and distributed infrastructure. This brings us to an important question. So how does public 5G SA compare with private 5G? Private 5G remains extremely important. It is well suited to factories, ports, mines, campuses, airports, and industrial sites where the organization needs local control, dedicated infrastructure, strong security, and predictable performance within a specific area. Public 5G SA has a different strength. It is designed for wide area coverage. It can support applications that move across geographies or operate across distributed locations. With slicing and quality of service, public 5G SA can offer more predictable performance than traditional best effort mobile connectivity. So this should not be seen as public 5G versus private 5G, where one replaces the other. For many organizations, the future will be a combination. Private 5G may be used for local control inside a factory or port. Public 5G SA may be used for wide area critical IoT, mobile assets, transport, field operations, and national infrastructure. The right choice depends on the use case, coverage needs, control requirements, security model, and economics. So what should we remember? First, 5G Standalone is more than an upgrade. It is the foundation for many of the advanced capabilities that were promised with 5G. Second, for IoT, the real value is not just connecting more devices, it is about connecting the right devices with the right level of performance, security, reliability, and control. Third, the 5G core is central to this. It enables intelligent control, stronger security, network slicing, and more flexible service behavior. Fourth, network slicing allows the same physical network to support different logical networks, each optimized for a particular application or customer need. Fifth, public and private 5G both have a role. Private 5G is excellent for local control, while public 5G SA can support wide area critical IoT. The Telia launch, therefore, is interesting because it shows how 5G SA is moving from trials and technical discussions into commercial services. For critical IoT, this is where 5G starts becoming less about headline speed and more about predictable, secure, and purpose-built connectivity. And that is likely to be one of the most important roles of 5G standalone in the years ahead. Thank you for watching. Hope you found this video useful. Please like, share, and subscribe, and let us know in the comments where you think 5G standalone will be making the biggest difference for IoT. Hope to see you again soon. Goodbye.